Hey guys, welcome to Learn Today IGCSE. This is a tutorial video for Physics, Paper 6 Alternative to Practical, Variant 6-1 for May June 2023 examinations. Question 1. A student investigates the balancing of a meter ruler. Figure 1.1 shows the setup. Okay, I would suggest you guys to just take a minute to understand the setup of the experiment before proceeding to read the rest of the question. Question E. The student places the meter ruler on the pivot at the 50 cm mark with the scale of the ruler facing upwards. He places an object Q with its center on the meter ruler at the 90 cm mark. Calculate the distance y from the center of Q to the 100 cm end of the ruler. So the answer is very simple here. As you can see, this is the distance of y. So the value of y that you will be writing here would be 10. Units are already given. Question B. The student places a load P of weight 2 newtons on the meter ruler. He adjusts the position of the load so that the meter ruler is as near as possible to being balanced. He measures the distance x from the center of P to the zero end of the ruler. I hope the instructions were clear. If it's not, just pause the video and try to understand what they are saying here. He repeats the procedure using loads of weight P to 3 Newton, 4 Newton, 5, and 6. The values of P and X are shown in the table 1.1. From what we can observe from this table is that as the value of your load increases, the distance of X is also increasing, meaning that when this load increases, the distance of X becomes bigger. The first question, describe the main difficulty that a student has when doing this experiment as accurately as possible. Alright, while performing this experiment, you need to ensure that the ruler is always balanced, meaning that a student might find it difficult to obtain an accurate balance for the meter ruler because the objects may slide from left to right while performing the experiment. And it is also difficult to judge the position for the center of the load. Since this question only provides you with 1 mark, you may answer any one of these 3 here. Question C. Plot a graph of P, y-axis against X, x-axis. Draw the best fit line. When it comes to plotting the graph, always start both axes at point 0, 0. First draw the x and y axis. X-axis is x centimeter and y-axis is the weight, which is P/Newton. Looking at the table, the range of x-axis is 10.2 centimeters to 36.8 centimeter. And for y-axis, it is 2 Newton until 6 newtons. For our scale on x-axis, we have 5 big boxes. So we can just set one big box as 10. And for y-axis, we have 5 big boxes. So we can set one big box as 1.2 newtons. After completing the x and y axis, just go ahead and plot all the points. And some of you were asking if you should draw a straight line or a curve. Well, it should be obvious once you have plotted your points that if it's a straight line or a curve. As you can see in the graph, this is more likely to be a curve, so draw a thin continuous line like this. And also ensure that your line should extend until the end of the graph. Don't just draw it halfway like this because it is not a graph. Question D. Use the graph to find the value of X required to balance the ruler when P is equal to 3.5 newtons. Show clearly on the graph how you determine the value of X. So you're supposed to show on the graph that you are using the graph. At P equals to 3.5 Newton, draw a line that touches your graph, and from there identify where it meets the x-axis. According to mine, it meets at the x-axis, which is equal to 26.5 centimeter. This is an acceptable answer because according to your marking scales, you have a range between 25 to 29 centimeters. Since the units are not given here, please do not forget to include your units when you are writing the value of x. Question E. Using apparatus from figure 1.1, explain briefly how you would determine the position of the center of mass of the ruler. Without any masses on the ruler, balance only the ruler on the pivot. The balance point here will show you the center of the mass. This is how you will be able to obtain a complete 2 marks. Question 2. A student investigates the cooling of water under different conditions. Figure 2.1 shows the setup. Again, before proceeding to read further of the question, always try to understand the setup of the experiment. We are given here with a beaker, a thermometer, and a bench holding all the apparatus. Question A. The thermometer in figure 2.2 shows the temperature theta r at the beginning of the experiment. Record theta r. This should be pretty simple and direct. According to the scale here, the temperature is at 21 degrees Celsius. Units are not given, so make sure you include them in your answer. Question B. The student pours 200 cm³ of hot water into the beaker. She records the temperature theta of the hot water at time 0. She immediately starts a stopwatch. She continues recording the temperature at 30-second intervals. The temperature readings are shown in Table 2.1. Part 1. Complete the column headings in 2.1. Temperature is recorded in seconds, so just write S here, and theta represents temperature, which is recorded in degrees Celsius. Part 2. Complete the first column of Table 2.1. The experiment is simple. You just record the temperature every 30 seconds starting from 0. So every 30 seconds interval is 30, 60, 90, 120, 150, and 180. Question C, Part 1. Calculate the decrease in temperature between t equals to 0 and t equals to 180 seconds. So you will get a change of temperature, which is 25. Part 2. Calculate the average rate of cooling R of the water using the equation R equals to change of temperature over change of time, where the change of time is 180 seconds. Include the unit. Okay, if the change of time is 180 seconds, meaning that it is between 180 to 0. So for your change of temperature, you also have to take from 0 until 180 seconds. So your change of temperature is already found, which is 25 over 180 will give you a value of R 0.138888. So how you would write this answer could be accepted in either 2 significant figures, which is 0.14, or 3 significant figures, which is 0.139. Question D. A student states the average rate of cooling of the water decreases as the temperature comes nearer to room temperature. So what they're saying is that as the temperature decreases to, let's say, room temperature of 25 degrees Celsius, the average rate of cooling for the water decreases. Part 1. Suggest one change to the experiment that you could make to test the statement. So if we were to test the statement, you can continue taking the temperature for a longer time until it is close to the room temperature. Part 2 suggests how to display the results to make it easier to see the trend in the rate of cooling. Now this is a standard answer. If the question asks you how you can display your results in order to see your trend, the most common answer would be to plot a graph. But since you're given with 2 marks here, make sure you mention according to the experiment that you should be plotting a graph time against the temperature. Question E. Explain briefly why it is good practice to read the thermometer scale at right angles. Let's say if you're looking at a scale within an angle, the reading might be slightly off. And we call this as parallax error. So reading a thermometer at the right scale angle is a very good practice because this will minimize parallax error. Question F. The student uses a measuring cylinder to measure 200 cm³ of hot water. She reads the scale at right angles. suggests another precaution to obtain an accurate reading of the volume for the water. So another precaution that you can take is that when you place your eye at a right angle, you want to read it at the bottom of the meniscus level instead of taking your readings over here. Or another answer is that to ensure that your measuring cylinder is on a horizontal surface. Question 3. A student investigates the refraction of light using a semicircular transparent block, Figure 3.1 and Figure 3.2 shows his ray trace sheet. Okay. This question may look complicated, but don't worry and do not get overwhelmed. We will solve it together point by point. Let's look at your first point. It mentions that on figure 3.1, draw the normal NL through the center of AB. Okay, so this is your line AB, and the center of AB can be measured by your ruler. Let's just put a small dot at the center. And now you're asked to draw your normal through the center AB, and we know that normal are perpendicular. So this is what your normal would look like, and we're going to label it as NL. Next, continue the normal so that it passes through the curved side of the block. This is the curved side of the block, and we have actually done it by passing through this curved side. Next, label the normal NL. We have done it as well. And label the point C where the normal crosses AB. So the normal crosses AB at this point, and we are going to label it C. Question B, Part 1. Draw a line DC below line PC. So this is the line PC at an angle I equals to 30 degree to the normal and to the left of the normal. Okay, to the left of the normal meaning that our line DC is going to fall in this region, and it mentions that it should be at an angle I equals to 30 degree, so we're going to have to use our protector for this question. Okay, since we're looking for 30 degree from the normal, make sure that 0 is aligned at the normal, and this is 30 degrees. So I'm just going to put an X over here. And you connect X to the center C. Since they're asking us to draw a line DC, C is already here. I will just extend this line and label the other end as D. So let's just recap. You have drawn a line DC below line PC at an angle I equals to 30 degree to the normal. This is your normal. And to the left of the normal. To the left. Just an extra information, I stands for incidence ray. This means that the direction of the ray would be in this direction. Well, they're not asking us to label, but I'm just going to leave it out here. Part 2. Mark with neat crosses X the positions for two pins on line DC at a suitable distance apart for this type of ray trace experiment, and label these positions P1 and P2. For those of you who is not familiar with this type of experiment, basically you're placing pins like this. So when they mention about placing your pins, this is what it looks like. Now they want you to place two pins on line DC. This is your line DC. You can use the reference to draw P1 and P2 by looking at P3 and P4. If there was a line connecting P3 to P4, you can see that the distance of P3 is short, and then P3 to P4 is something like this. So if I were to draw P1 and P2, I would use the same scale to put P2 over here, and P4 is a little bit further, so I'm going to do the same thing by placing P1 over here. Okay, so we have marked it with neat crosses X and have labeled it with P1 and P2. Question C. Alright, everything that we have to answer from question C would be on the ray trace. I'm just going to put the screenshot of question C below here. The student looks from the position of the eye, shown in figure 3.1, to observe the images of P1 and P2 through side AB of the block. He adjusts his line of sight until the image of P1 and P2 appear one behind the other. He places two pins P3 and P4 between his eye and the block so that P3 and P4 and the images of P1 seen through the block appear one behind the other. The positions of P3 and P4 are shown in figure 3.1. Question Part 1. Draw a line joining the positions of P3 and P4. Continue the line to AB. Okay, this is quite simple. We just need to join the positions of P3 and P4. This is your line AB, and we will just extend the line until it reaches AB. Bullet point 2. Label E the end of the line furthest from AB. Okay, for all the pins P1, P2, P3, and P4 to appear one behind the other, they should be on a straight line like this. So from AB, the end of the line which is furthest away would be over here. So let's label this point E. Okay, let's go back to question C. We have done the first part of bullet point 1 and 2. Now part 2. Measure the acute angle alpha between the line NL and the line CE. This is the line NL and this is the line CE. So there are two possible points here, one being this angle and the other one being this angle. Since they're asking for acute angle means it is below 90 degree. So the angle that we're looking for is this region. And we're looking from 0 until this line. And according to our protector, we will get an angle of 49 degree. According to your marking scales, you can write any answer from the range of 47 degree to 51 degree. Question D. State one precaution that you would take in order to produce an accurate ray trace. Well, as I shown you an example of a ray trace experiment earlier, the thickness of your lines may affect the angle measured. So make sure you are using sharp pencil. You should also view your ray trace from the base of the pin like this. Also ensure that you are placing your pins as far apart as possible. And the last thing is to make sure that your pins are vertical and not slanted like this or like this. Question E. The student moves the transparent block to a new position on the ray trace sheet, as shown in figure 3.2. He places pins P1 and 2 on line DC in the same positions used in B part 2. He observes the images of P1 and P2 through the curved side of the block. This is the curved side of the block right now. He places pins P5 and P6 between his eye and the block so that P5 and P6 and the images of P1 and P2 seen through the block appear one behind the other. He draws a line CF through the positions of P5 and P6. So through the positions of P5 and P6 means that P5 and P6 are placed somewhere on line CF. Part 1. Measure the acute angle beta between the line AB and the line CF. An acute angle is less than 90 degree. There are two possible angles between the line AB and CF. It could be this or this. Since we're looking for acute angle which is below 90 degree, the region of angle we're looking for would be here. Okay, place your protector accordingly and we will start from 0 here until the point F. You should be able to get an angle within the range of 70 degree to 73 degree. Part 2. Calculate the angle theta between the line CF and the normal to the line AB. Show your working. Okay, this question wants you to calculate. This means that you do not need to measure any angle but you need to show your calculation on how to obtain theta. So they're looking to find between the line CF and the normal towards AB. The total angle here would be 90 degree angle. So the balance would be 90 minus 70 degree which is 20 degree. You might get a different value here according to whatever angle that you obtained previously in part 1. Question F. A student suggests that angle alpha should be equal to angle theta. State whether your results support the suggestion and justify your answer with reference to the results. Okay, angle alpha as measured previously is 49 degree and angle theta here is 20 degree. So this means that the student's suggestion is wrong. And for justification, you can mention that the expected result from the student is beyond the limit of experimental accuracy. Question 4. A student investigates the change in resistance of a lamp filament when the current in the lamp is increased. The following apparatus is available: a power supply, a low voltage filament lamp, an ammeter, a voltmeter, and connecting wires. Other apparatus normally found in a school laboratory is also available. Plan an experiment to investigate the change in resistance of the filament lamp when the current in the lamp is increased. Resistance R is given by the equation R equals to V over I, where V is the potential difference PD across the lamp and I is the current in the lamp. Okay, this is a 7 marks question. And in order to solve the question with planning an experiment, it's actually quite simple because all you need to do is answer the question according to its bullet points. Firstly, it mentions that you should draw a diagram of the circuit used. For this, we're going to have to look at what apparatus is given to us. So this is how the diagram of your circuit should be. This is your power supply. You can also show it in batteries like this. A low voltage filament lamp is shown. An ammeter is always placed in circuit to your component. A voltmeter, which is placed across your component in parallel, and connecting wires, all this. Next, explain briefly how to do the investigation, including how to change the current. So there are 2 things here that we have to pay attention. One, explaining briefly on how to do the investigation and how to change the current. Okay, how to do the investigation. To answer this, you can explain how this circuit or how this experiment is being set up. So the first thing is that you have to close your switch, and when your switch is closed, you will have current flowing. And since we are looking for resistance, we need to take the reading of the voltmeter here and also the reading of the ammeter, which shows our current. So that is everything that we are going to write out to explain briefly on how to do the investigation. The question is talking about investigating change in resistance when your current is being increased. So you have to repeat your experiment by changing the value of your current to see how it will affect your resistance. And how you can do this is by increasing your power supply. Okay, so done. You have answered how to do the investigation and how to change the current. Let's look at our third point. Draw a table or tables with column headings to show how to display your readings. You are not required to enter any readings in the table. Okay, we are investigating the experiment between resistance, voltage, and current. So in our table, these are the 3 values including units that you should display. And now to our last bullet point. Explain how to use the readings to reach a conclusion. As I explained previously, the best way to display your results is by plotting a graph. We are changing our current to see how it affects the resistance. So the graph that you are going to plot would be resistance against current. You have answered all the bullet points and you will get a complete 1, 2, 3, 4, 5, 6, and 7 marks for planning your experiment. That is all for this paper. Thank you for watching the video till the end. I hope it was worth your time. And if you have any questions, please ask me in the comment section below. Bye!